is Sulak Kumar from SMS College of Technology and Department of Computer Science and Engineering. Now I am going to tell about what is deadlock and system model and characterization and process scheduling and synchronization. So first of all, deadlock. So the deadlock is considered the following topics like a system model and a deadlock characterization and methods for handling deadlocks and deadlock prevention and deadlock avoidance and deadlock detection and recovery from deadlock. So first of all, first one I'm going to tell about deadlock. So a processor requests resources. So if the resources are not available so at the time, so the process enters a waiting state. So sometimes a waiting process is never again able to change state because the resource it has requested or held by other waiting process. So this situation is called a deadlock. So system model. So system consists of a number of resources. Resource type R1, R2, and RM. So we have a CPU cycles and a memory phase and input-output devices. So each resource type RA has a WA instance, and each process utilizes a resource as follows: and request, use, and release. So a process must request a resource before using it, and must release the resource after using it. So then a process may request as many resources as it requires to carry out its designated task. So obviously the number of resources requested may not exist the total number of resources available in the system. So in other words, a process cannot request 3 printers if the system has only 2. So deadlock characterization. So necessary conditions. Deadlocks can arise if your condition hold simultaneously. For example, mutual exclusion. So only one process at a time can use a resource. So second one, hold and wait. So it means a process holding at least one resource is waiting to acquire additional resource held by other process. So next one, no preemption. A resource can be released only voluntarily by the process holding it after that the process has completed its task. So next one, circular wait. So there exists a set of P0, a set of waiting process such that P0 is waiting for a resource that is held by P1 and P1 is waiting for a resource that is held by P2. So Pn-1, so is a waiting resource that is held by Pn and Pn is waiting for a resource that is held by P0. So this is the necessary conditions. So next one, resource allocation graph. A set of vertices V and a set of edges E. So V is partitioned into two types. So one is an active process and it is a resource. So P and R. So P is a process, R is a resource. So we have a P1, P2, Pn and R1, R2, Rm. So request edge, directed edge and assignment edge is a direct edge of Rg tends to Pg and Pa tends to Rg. So resource allocation graph of process, and we have only one circle and a resource type with a 4 instance. We have a square shape with the 4 instance. The PA requires instance of RG. So PA tends to resource of rectangle. PA is holding an instance of R. So we have the PA is holding into message into PI. So example of resource allocation graph. So we have here we have a resource instance of P and process P and resource R and E for edges. So P1, P2, P3 and resource of R1, R2, R3, R4 and E and P1 tends to R1 and R2 tends to R3 and R1 tends to P2 and P2 tends to R2 and R2 tends to P1 and R3 tends to P3. So resource instance. So one instance of resource type and R1, two instances of resource type R2 and one instance of resource type R3 and three instances of resource type R4. So the process states the process P1 is holding an instance of resource type R2 and is waiting for an instance of resource type R1. So process P2 is holding an instance of R1 and an instance of R2 and it is waiting for an instance of R3. So process R3 is holding an instance of R3. So resource allocation graph with a deadlock. So here P1 tends to R1, tends to P2 and tends to R3 and tends to P1, R2 and then R2. See here with he has some creating a cycling function. So that is a created deadlock. So another one is a P2 tends to R3 and R3 tends to P3 and P3 tends to R2 and R2 tends to P2. So here also we have a creating a circle. So that is called a deadlock. So graph with the cyclic but no deadlock. So here with no cyclic formation because of one P process avoided from the another processes. Basic fact. So if a graph contains no cycles means no deadlock. So if a graph contains a cycle, so then if only one instance was a resource type, then the deadlock is occurred. So if a several instances was a resource type, then possibility of deadlock is available. So methods for handling deadlocks. So ensure that the system will never enter deadlock state. So we have a deadlock prevention, deadlock avoidance. So allow that the system to enter deadlock state and then recover. So ignore the problems and pretend the deadlocks never occur in the system. So used by most operating systems including Unix. So we can deal with the deadlock problems in one of three ways. So we can use a protocol to prevent or avoid deadlocks, ensuring that the system will never enter a deadlock state. So we can allow the system to enter a deadlocked state, detect it and recover. So we can ignore the problems altogether and pretend that the deadlocks never occur in the systems. These are the deadlock. Thank you.